I'm Nilesh Bhavsar. Today I am giving the presentation on device drivers. What are the importance of device drivers in the operating systems and the embedded systems and how to develop the device drivers. Let us start with the first. What is mean by device drivers? A device drivers is nothing but a set of program which is written to perform the particular task. This set of functions or set of program which is written in a high level language just like in the C, C++, Java, Hash, .NET. This program is directly interact with your devices to send the control commands, to read the data, to write the data, or to perform the specific task. See, this is the simple block diagram or self-explanatory block diagram which define what is the use of device drivers. So here these are the peripherals, nothing but your hardware. This is graphics card, hard drive, cameras and the mouse, and this is your application. If I want to access the camera, so I will access through the operating system, and here this is the program. This program means short of program which is written to perform the particular task, nothing but to access the pictures or videos or the cameras. So for each device some specific program which is written. This is nothing but the drivers. So in the shortly we can define the drivers is nothing but some set of function which is written to perform the particular task. These are directly interact with the hardware to perform the specific task. So device driver is a computer program that allows a system to interface with the hardware device, just like your printer, Bluetooth, mouse, cameras, hard drive, all etc. etc. It is a translator between the operating systems and the application. It is nothing but the intermediator between your operating systems and your peripherals. So why device drivers? A typical computing system like laptop, computer, cell phone, PDA deals with the variety of device. They are communicating with the different peripherals. So for to perform the specific task, specific function, they have to return the some set of programs is nothing but your drivers. Instead of the adding code every application, just like if you having the different peripherals, number of peripheral more than 10, 20 or 30 depends upon your computing system. So the operating system provide a single point of interface to all device by hosting the device drivers, and this operating system will provide the protection and the security for the device drivers. The device drivers are essentially shared dynamically linked libraries. They can perform the different function: read, write, read only, write only. Okay, what do you with the files? Files, the functions are nothing but to open the file, close the file, read, write, all. So device space, to return the device driver for the particular peripherals, they are classified according to the device space, just like the major numbers and the minus number. For example, the printer have the major numbers since the purpose is same, the minor denote the specific printers. Let us analyze the controller UART drivers. If I want to define the UART drivers, so what should I have to take care? The starting point, that is UART directory function, system directory, and the uses of the devices through the device tables. So general device drivers related files we have to return, that is device.c, device.h, UART file, that is UART.h, definition of physical features of the UART, all the files in the UART directory that implement the operating related to the UART. Means for the development of the UART drivers, we have to write the UART control.c, UART initialization.c, UART put character.c, UART write means UART transmit data, UART read to read the data from the peripherals, and UART get character.c. These all the files we have to create and write their functions. So on both devices are called internal peripheral and one outside are called the external peripherals. So for the UART, to establish the communication between the peripherals and the operating system through the UART, so this is the channel I needed, that is UART transceivers, RS-232, DB9 connector, and your laptop socket. Through this medium, the UART peripheral, you means your peripheral will be communicate to your application through that communication, through that channel. So the embedded processor interact with the peripherals devices through the set of control and the status register. To develop the UART drivers, we have to perform the different function, that is we have to transmit data through peripheral or read data from the peripheral. So we have to access their status register, or we call as a, in the controller language we call as a SFR, special function registers. This special function register which is written in the UART initialization.c APIs. UART initialization API. The function of the UART initialization API is used to initialize the SFR function. They are going to perform the read operation and the write operation. The register are the part of peripheral device. Register within the serial controller are different from those of the timers. So the keywords for the development of the UART device drivers, we need to use the C functions, that is the keywords. Volatile should be used when declaring a pointer to the device. Bit pattern, testing, setting, clearing, toggling, shifting bit mask and the bit field, and the C structures which is required to access their special function register or the global variables. So see this general block diagram, which is the difference between the how operating system which differ from the embedded system. So look at this. In the board, at the left hand side, this is the operating system, and the right hand side, that is the embedded system. The embedded system, your application, these are communicating to the peripheral through the only the device driver which is written in either C, C++ or in the assembly. But apart from that, in the general purpose operating system, the application process which is communicating to the peripheral through the operating system, these are nothing but your controller controlling the all activities through the peripherals. So for the development of the device drivers, that is the ISR, interrupt service routines, is very important. So device drivers, that is command one run short code single ISR, means some specific program or set of instruction which is written to perform this particular task. This function having the different ISRs. So device driver development steps. How you can develop the device drivers? First is that an interface to control and the status register. You have to learn about the each peripheral status registers, variable to track the current state of the physical and the logical devices, that is major and minor device numbers and device name. A routine to initialize the hardware to know state. An API. Next is to define the API, just like in the UART we are talking about the UART. So UART initialization, UART transmit, UART read. So these are the APIs you have to return. Next and most important, this is nothing but the interrupt service routine. Example of the server driver, read the text for the explanation and general example of the timers. Now let us look the UART driver of the embedded. Study of the driver's logical device, that is layer of the top your device and your lab tools. So most of the shift registers and the pointers, variable, keywords, volatile, which is used for to development in the development of the device drivers. So these are the different logical operators. We can use that operator, you can develop the device drivers. And the relevant to shift, bitwise operator and device bitwise operators and the logical operators. By using that, you can develop the applications. Thank you very much for listening this video. If you are interested, so please click on the alarm bell, so you will get the notification about your upcoming videos which is based on the embedded system. Thank you very much.